In the previous video, we looked at authorization and how RBAC or role-based access control can be used to provide fine-tuned access control policies. In this video, we will see a demo of RBAC in action. We will create two different users named Frontend and Backend. We want to write RBAC rules that allow the Frontend user to create pods in the Frontend namespace and the Backend user to create deployments in the Backend namespace. The first step is to create two users called Frontend and Backend. We looked at various authentication techniques in a former video. For this demo, we will use a static file to create additional users and pass it to Minikube. Since the Minikube is on VirtualBox, we will need to mount the folder containing the static file to Minikube. We do that via the VirtualBox shared folder interface. Here we map a folder in a local machine to where local cube certs mini folder in Minikube. Next, in a local folder, we create a file called users.txt. In that file, we add two users. Each line contains three columns. The first column is the username, second column is the password, and the third column is a user ID, which has to be unique for all users. I've created two users called Frontend and Backend. We will now start Minikube and pass on a parameter to the API server so that it allows users from the file that we created. Minikube start extra config equals API server.basic auth file where lib minikube certs mini users.txt. Let's add the users to kubectl config. We take a look at the current config by typing in kubectl config view. To add the frontend user, type in kubectl config set credentials frontend, username equals frontend, password equals frontend. Similarly, add the backend user. Let's look at kubectl config again to see if the users have been added. We can see two new users in the users section. Now that the users have been added, we need to figure out how to configure kubectl so that it fires command as a particular user. Kubectl has a concept of a context. The default context is called Minikube and it uses the Minikube user to log in. Let's set context for the frontend and the backend user so that we can run kubectl as that user. To add context for the backend user, type in kubectl config set context backend user equals backend cluster equals minikube namespace equals backend. We added the namespace since the default namespace for this user would be a namespace with the name backend. We haven't created the namespaces yet. We will do that soon. Here's how the kubectl config file looks now. Similarly, create the context for the front-end user. We need to create the namespace now. We'll use a YAML file to create the namespace. Here's how the YAML file looks. This file and the other files for this video are in the Kubernetes _RBAC folder in the GitHub project. This file creates two namespaces, frontend and backend. To create the namespaces, type in kubectl apply -f namespaces.yaml. We'll now create policies that allow the backend and the frontend users access to the corresponding namespaces. Let's start with frontend first. Here's how the YAML looks. On the top we have the role. The namespace frontend is specified in the metadata. In the rules we add a rule that allows this role to get, watch, list or create pods in the core API group. In the next section we create a role binding, again in the frontend namespace, that assigns the role frontend pods to the frontend user. The API groups is a group of the subject. To create the role and role binding, use kubectl apply -f frontend_rbac.yaml. This creates the role and the role binding. Let's switch context to the frontend user now. To do that, type in kubectl config use context frontend. We will now be using kubectl as a frontend user. To see if the user can perform an action, use the can I option in the kubectl auth command. For example, to check if the user can get pods in the current namespace, type in kubectl auth can I get pods. The current namespace is frontend since that is what we changed the context to. The frontend user can list pods in the frontend namespace, so it replies with yes. Let's check if it can get pods in the backend namespace. To do that, type in kubectl auth can I get pods namespace equals backend. This says no, since the frontend user does not have access to list pods from the backend namespace. Similarly, we create the role and role binding for the backend. It is similar to the front end except that the rule allows access to extensions API group and get, watch list and creating deployments. We will have to switch back to the Minikube context and then we create the role backend role and role binding. We switch context to the backend user. Let's see if we can list deployments by typing in kubectl auth can I list deployments. It says yes as we expected. Let's see if we can list the pods. We can't since the rule only allows deployments and not pods. So far we have seen how to create two users and give them access to their own namespaces. However, there is another use case where we want to give a user certain access in all the namespaces. That is, let's see how we can give the front-end user access to list pods in all the namespaces. We first create a cluster role that allows getting and listing pods. Next, we create a cluster role binding. In subject, we specify the backend user, and in the role, we give a reference to the cluster role. We now create the role using kubectl after switching to the Minikube context. After creating the role, we switch back to the front-end context. Let's see if we can list the backend pods using the front-end user, since the front-end user now has a cluster role that allows it access to the listing pods in all namespaces. Yes, we can. We can also use role binding to bind a cluster role to a user in a particular namespace. In our case, we could bind the front-end user to the cluster role in the backend namespace, in which case the front-end user would be able to list pods in the backend namespace, but not in the default namespace. This finishes our video on role-based access control. We have seen how to create role and role binding to control access to a namespace, and cluster role and cluster role binding to control access in the cluster. This also finishes this section on authentication and authorization in Kubernetes. See you in the next section.